Okay, so we are looking at the word problems of section 3.1. So we did one earlier, and now the number 3, example 3. A local coffee shop wants to produce coffee cups. The shop has determined that when X coffee cups are made, the cost per coffee cup is determined by this function given here. C of x is equal to 1/2 x squared minus 8x plus 68. What is the minimum cost? Now, there is something missing in this problem. It should have been mentioned what are the units for the C for the cost. And I believe it is cents per cup. But yeah, when we do the, solve it, then we will use those units. Okay, now this is again a quadratic function. A is equal to 1/2, B is equal to -8, C is equal to 68. So these are, this is a parabola which is opening up because A is one positive, so it means this is going to be the min point. So it's the vertex is going to be your min point. So it means we need to find the vertex, the coordinates of the vertex. Now, min point means that it will give us a minimum value, and that's what we want. We want to find the minimum cost. So it will give us the minimum value of the function. What function? The function that we have. So we start by finding the first coordinate of the vertex, which in this case will be, again, always minus b over 2a. Here it is the x value. So it will be equal to negative of -8 over 2 into 1/2. Now the negative and negative become positive, and I have 8 on the top, and 2 into 1/2 is 1, so I get 8. So x is 8, means 8 cups, and that will give us minimum cost. So min cost, okay, maybe I'll write that later. So we need to find basically now cost at 8, so which is 1/2 8 square plus minus 8 into 8 plus 68. Do the calculation. So the first is 1/2 64, and these give me 64 plus 68. So this is going to give me, the first term will become 32, and then these two combined together give me 4. So I have 36. So the min cost is equal to 36 cents per cup. It cannot be the dollars. So that will be the answer for the first part. Second part, how many coffee cups should be produced to yield the minimum cost? So we have already done those calculations. Remember this over here. So we'll say 8 coffee cups should be produced to yield the minimum cost. So okay, so the last problem here, Dan has 2400 feet of fencing to fence in a rectangular garden. So A part is saying find a function that models the area of the garden in terms of the width x. Now in this question we are not given the function like in the previous two examples, but so we have to first come up with the function, and then in the second part we will talk about the how to find the maximum or minimum, whatever the question is asking. Now this is something we just did in 2-point modeling. So it says find a function that models the area of the garden in terms of the width x. So it's a rectangular garden. So width is this one, so I'll call this x. This I can call any other variable. Let's take y. So you can see here the what is related to the rectangle, as we were doing in modeling, often area and perimeter. And that should make sense because the question is asking us to model the area. So we need to write the area function. So area function is or the formula for area, which is a is equal to x times y. And also note that the fence will be go around the garden, right? Around this whole thing. So what is this? This is the perimeter. So the perimeter P is equal to 2x plus 2y. Now, one of these things is given to us, either the value of the P or value of A. So you read the question again. So it says Dan has 2400 feet. Now, if it was area, here is a hint. If this was the value for area, the unit should have been feet squared or square foot, because it's just foot, it's the length, so it is the perimeter. So now in place of P, I will write 2400. So 2400 is equal to 2x plus 2y. And then simplify this, we get x plus y equals, I divide both sides by 2. So I end up getting x plus y equals 1200. So that y is equal to 1200 minus x. Now I will take that value and plug it into A. So therefore A will be equal to x into 1200 minus x, or A is equal to 1200x minus x squared. So this is our function. So B part is saying find the rectangle dimension, find the dimensions of the rectangle that will maximize the area. Now dimensions mean, in this case, the length and the width. What should be the values for the length and the width, so that there is maximum, I mean the whole fence is used, and it yields the maximum area that he could cover. So we see that this is a quadratic function and it's a parabola open down, and so it's a maximum point, so it will yield a maximum value. So starting with the x coordinate again, okay, let's write our AB. So A is -1 and B is 1200 and C is 0. So x will be minus b over 2a, so it will equal to negative 1200 over 2 into -1. So the negative and negative become positive, and 2 cancels 1200 and give me 600. So the x is the width, so width should be 600 feet, and the maximum area will be when I plug in the A 600 for x in over here. But I will not do that. The question didn't ask me to find the maximum value of the area. It asked me to find the dimensions that will produce the maximum area. So what I will do now is go to, so x is equal to 600. And now we will use this to find the y, plugging it in this formula. So y will be equal to 1200 minus 600, which is equal to 600. So x is equal to 600 feet, y is equal to 600 feet. But this is not enough because x was given but y was not given. So it's better to write it that either you can write in this that the dimensions that yield max area, or you can write the whole word maximum area, are 600 feet by 600 feet. So this is a very common way of writing. You must have seen it on the any rectangular thing you buy. For example, if it's a frame, picture frame, or it's a book or a notebook, so it will say whatever the units are. If it is in inches, 8 inch by 11 inch, 16 inch by 34 inch, whatever. So this symbol is used, the X type symbol or a cross. So that's how we read it, 600 feet by 600 feet. So that is the dimension. Or you can say area will be maximum when width is equal to 600 feet and length equals 600 feet. So this is how you can find the answer. Okay, so these are how we do these word problems. Now, if we have a function which is not quadratic but cubic or higher degree, then we don't have a way of finding the max value or the min value. But that is something you will learn if you take calculus 1. That's where you learn to find the max and min values for those type of functions. Okay, that's all for now.